Welcome back to this video series on geometry. Today we're going to be talking about parallel lines and a transversal. So we'll start off by drawing two parallel lines. And parallel lines by definition mean that they have the same slope. So at no point along these paths and these lines extend to infinity in both directions. At no point along either one of these lines will they ever cross or touch each other. A transversal is simply a third line, and by definition a line is a straight line extending to infinity in both directions. A third line that crosses over the set of parallel lines. And as you might notice, each one of these now creates angles. So this third line creates 8 angles, 4 on each parallel line, kind of like an intersection. Now there's multiple types of angles. We went over the last video about vertical angles, and you might recognize some of those vertical angle pairs. So for example, 2 and 3 are vertical angles, but 1 and 4 are also vertical angles. And similarly, 6 and 7 are vertical, and 5 and 8 are vertical. So there's a lot of types of angles. We've already talked about vertical. Now alternate interior. When we talk about interior angles, we're talking about the inside of the parallel lines. So exterior would be on the outside, interior would be on the inside. So we're looking at this 3, 4, 5, 6. Those are our interior angles. There are alternate interior angles which cross over the transversal. So 3 and 6 are alternate interior. 4 and 5 are alternate interior. We also have same side interior. So as that implies, 3 and 5 are interior angles but on the same side of the transversal, and 4 and 6 are interior angles but on the same side. So 4 and 5 are alternate interior, but 4 and 6 are same side interior. Now the reason we went over complementary, supplementary, and vertical angles last time is because that plays directly into what we're learning today. If we look at the relationship between vertical angles, we know that those angles are equal to each other. 2 and 3 are going to be equal. 5 and 7 are equal. Or sorry, 6 and 7 are equal. 5 and 8 are equal. 1 and 4 are equal. But what about the relationship between 4 and 6? Those are same side interior angles. If we draw it on its side right here, we'll take just that segment. So this is our transversal here. This is angle 4, and this is angle 6. If you notice how these two, I guess, are related, these two lines right here, these are parallel. That'll be this line right here and this line right there. Angle 4, if you transpose that over here, we just slide it over. Angle 4 and angle 6 combine to make a straight line, or an angle of 180 degrees. So same side interior angles, like 4 and 6 or 3 and 5, those are supplementary. And I'm going to say that those add up to 180 degrees. Now, conversely, if we look at alternate interior angles, so say we're talking about now 4 and 5, alternate interior angles are not supplementary. If we take this piece of the pie 5 and this piece of the pie 4, we try to add those together, we're not going to get a straight line. But what we would get is, imagine if you take this angle 5 and transpose it up here. 5 looks awfully similar to 1, and that's because alternate interior angles actually have the same relationship as vertical angles. They are congruent. And congruent just means they have the same value. Equal means they're exactly the same. Congruent means they have the same value, but they're not the same angle. So 4 and 5 have equal angle measures, and they are congruent angles. Now, corresponding angles, we already mentioned that a little bit for the example of 5 and 1. 5 and 1 are corresponding angles because they hold, I like to think of it as the corresponding place, the same place in the intersection. If I have one intersection up here and I'm in the top right spot, well, another intersection down here, the same top right spot. Those are corresponding angles. Bottom left spot of this top intersection, bottom left spot of that bottom intersection. Those are corresponding angles. So corresponding angles are also congruent. So if we do a quick example here, I'm going to go back to black. I'm going to draw a set of parallel lines, and then we have an angle measure of 71 degrees here, and we're looking for what is the measure of angle Y, angle X, and angle Z. Feel free to pause the video and do this on your own, but I'm just going to go right ahead. The first thing that we'll recognize is that this angle measure of 71 and Y are vertical angles. Well, that means that Y has the same angle measure as 71. So Y is equal to 71 degrees. Now, what about 71 here and Z? Those are corresponding angles. So what is a corresponding angle? They have the same place at the intersection, so they are equal to each other. Z is also equal to 71 degrees. Now, what about 71 and X? Well, they're not interior angles, right? Because X is on the outside, so it can't be inside, same side interior or alternate interior. They're also not vertical angles, because, well, this angle you can obviously see by the diagram, which you're never supposed to trust. The diagram is a lot larger than 71. But what if we found an intermediary? For example, let's use this spot right here, and we're going to transpose X over there, because these are corresponding angles, right? So this angle and X should have the same angle measure. Well, now if we look at X and 71 together, we can see that those form this straight line right here. So X and 71 are supplementary, which means X plus 71 equals 180, and we can write that on our calculator, do it by hand, and we get that X is equal to 109 degrees. And another really cool thing about knowing how to use angles this way is you can actually use angles and then plug in dimensions, and you can figure out a lot more stuff about parallel lines and geometry in general. So I'll go through this quick example, and you can apply this to a lot of other things. But say, for example, that we have two parallel lines here. Now we're given that this angle measure is 135 degrees, and the length of the transversal between the parallel lines, so not the entire line, just the section in between these 2 points, has a distance of 12. And what if the question was, how far apart are these two parallel lines? Well, we know what angle measure this is. We know that this angle measure and this angle measure right here are supplementary, so we'll just start filling in information there. 135 minus 180, well, that's a 45-degree angle here. What else can we figure out? Well, we can go back to right triangles, and we can actually create a right triangle right here. We'll just drop that down. We know that this is 90 degrees, and if we're trying to figure out what that value is, notice now we have a right triangle. And we can use our trigonometric identities. In this case, we'll be using sine. So the sine of 45 degrees is equal to opposite over hypotenuse, that's x over 12. Now you can just plug that into your calculator. We'll do sine of 45, move the 12 to the other side, so x is equal to 12 times the sine of 45. And then if we just hit enter there, we get that x is equal to 8.48. And we've used our identities for parallel lines, a transversal, trigonometric identities, and then just simple geometry to figure out what the distance between the parallel lines is. So we'll leave it there for today. Have a great rest of your day, and I'll see you next time.